Alright, this problem says the uniform boom shown below weighs 700 newtons. So this boom weighs 700 newtons and its weight acts at its geometric center. And the object hanging from its right end weighs 400 newtons, that is 45 degrees. The boom is supported by a light cable and by the hinge at the wall. So there's the hinge. Calculate the tension in the cable and the force on the hinge. Force off the hinge on the boom. Okay. Does the force on the hinge act along the boom? Okay. So what's happening is here's the boom, here's the weight hanging. This cable is pushing the boom into the wall and the wall pushes back. So, okay. So let's call this the reaction force. We'll call that. Here's the weight of the boom and tension in the cable. Okay. So here are the four forces acting on this boom. 1, 2, 3, 4. Okay. And what we'll do is, so for this problem, we might have to apply all the equations, both of the equations. Okay. So what are they asking us? Well, tension and FR. Okay, so they're asking us to find those two. Okay. Now also tension. This is one quantity, and you have to find the two components, x and y component of that. So there are three unknowns, so you'll need these three equations. Okay. Everybody understand that? Okay. And again, we are always going to set our axes up like that. So let's call this okay. So the y components are tension sine 45, tension sine 45 minus mg. Mg is 700 newtons. Minus 700 minus 400 plus Fy equal to 0. So T sine 45 plus Fy equal to 1100. So that's what the y component of the equation gives us. Let's look at the x component of the forces. Okay. Now these guys do not have any x component, so this guy has an x component, and that's equal to fx minus t cosine 45 equal to 0. All right, so we have the x and y component of this reaction force in terms of the tension. Okay. Now we'll use the torque equation and calculate the tension. And now you have to be smart about this. See, you can calculate the torque about any point, like I said. If the sum of the torques is 0, the sum of the torques of all the forces acting on the system will be 0 about any point. The smartest point to pick is this one. Why? If you calculate the torques about this point, the torque of this guy will be 0. The only torques that will come into play is this guy, you know these forces, and tension. So tension will be the only unknown. Okay. So you always want to pick the axes at a point where one of the forces are acting, so that that force doesn't come into the equation. Okay. So we'll calculate the torque about this point. Okay, now we'll need to assume a length for this thing. The length will cancel. If they do not give you the length, that means the length will cancel. Okay. This provides a clockwise torque. This guy provides a clockwise torque. Okay. The moment arm for this guy is L by 2 cosine 20. And the moment arm for this guy is L cosine 20. Okay. This guy, this force can be the tension. There is the x component of tension, there's the y component of tension. And the moment arm for the x component is that, and that is L sine 20. And for this, it's L cosine 20. Okay? They both are counterclockwise torques. All right, so let's do one at a time. This is a clockwise torque. The moment arm is L by 2 cosine 20. So and that's a clockwise torque, so that'll be negative. Minus 400 newtons times L cosine 20. Plus, so this was a clockwise torque, this was a clockwise torque. This is T cosine 45, and there's the moment arm. And the moment arm is L sine 20. And that was a counterclockwise torque, so that's positive. And then T sine 45. T sine 45 is that. I know this diagram is messy, but such is life in these statics problems. You have to write down a and you see every term has L. So there's the tension. Okay. Again, interestingly enough, the tension is 780 newtons. See, this boom by itself weighs 700 newtons, and here's another 400 newtons. So you're supporting this, and that cable has a tension of only 780 newtons. Okay? Now let's calculate the reaction forces from these guys. Okay? So Fx is, what is Fx? T cosine 45 and the other equation is T sine 45 plus Fy equal to 1100. All right, so there's the tension and the reaction force of the hinge on the boom. Okay. Again, we had to find three unknowns, 1, 2, 3, and so we needed three equations, and we needed the sum of the forces equal to 0 and the sum of the torques equal to 0. Okay. Any questions before we quit that one? So there's the reaction force, and that's the tension. Those are the two things we calculated. Okay.